School of Physics will present a dynamic way to solve the physics numerical. The statement of the current numerical is the 10 bricks, each 6 centimeter thick and mass 1.5 kg, lie flat on the table. How much work is required to stack them on the top of another? First of all, it is important to understand how the bricks are lying on the table before stacking. The answer is that the bricks lies flat on the table according to a numerical statement. They have the same level and not a difference of height. While the figure 2 is shown that the bricks are not arranged in this way before stacking 10 bricks one on each other. While some bricks are here positioned randomly in the form of stacked 2-3 bricks. Now we will see in the simulation how the bricks are stacked over each other according to the numerical statement. Here we can see that this is the first brick lies flat on the table and the thickness of the brick is 6 centimeter according to the statement. We can see it is 0.06 meter in SI units. When the second brick will be stacked on the first brick, it will be uplifted equal to the thickness of the first brick, and the third brick will be uplifted equal to the thickness of the two bricks. In the similar fashion, fourth bricks will be uplifted equal to the thickness of 3 bricks. Here it is important to note that we will only calculate the work by the gravitational field, while we will not calculate the work to take the bricks to this one. Here we can see that when brick move linearly, it covers some linear displacement, and in doing so, and some amount of work will be also used. But we will not include this work in our numerical. We will only calculate the work for stacking bricks in the gravitational field. So we can see that how the 10 bricks actually can be stacked on each other and what things happened in this way, and the gravitational acceleration will be cause force of gravity, and here we can see that the dimensions and the distance by which the different bricks will be uplifted. The next important thing is to extract the data which is given in the numerical, and we can see that in the numerical statement dimension of the bricks are given only. The mass of bricks is 1.5 kg and the thickness or height of the brick is equal to 6 centimeter, and we will use a gravitational acceleration value of 9.8 meter per second square. In the next step we will find what we have to calculate in the numerical according to the numerical statement. According to the numerical statement, we have to calculate the total work done in stacking 10 bricks as shown in the simulation. So we have to find WT, or the total work done. Now the work principle can be used to find out the total work done in 10 brick stacks. Work energy principle can be used to solve this numerical or to find the total work done. According to this principle, work done on a body or object in gravitational field is equal to the change in potential energy of that body, and WT is equal to mgh. Here the h is the change in height for the 9 bricks. Now we will apply the work energy principle or work done in gravitational field. Here is the first method is presented. we can see that the first brick is not uplifted, so the change in height for that will be 0. And for the second brick, the change will be equal to the thickness of the first brick. And for the third brick, it will be equal to the total thickness of 2 bricks by which it is uplifted. Is similarly the case for the 4th, 5th, and 6th up to 10th bricks. Here the height change in height for all the 10 bricks, we will put the value of mass 1.5 kg and gravitational acceleration 9.8 meter per second square, and add up all these subsequent heights for the bricks, and we will multiply and mathematical operation that will be equal to 40 Newton meter or joules. Another method of calculation can also be used to calculate the change in potential energy or the total work done. In this method, we will calculate the change in potential energy for individual brick and add up all these. This will be equal to the total work done in stacking 10 bricks over one and each other. Here we can see that for the 10 bricks, the individual change in potential energy will be equal to the work done has been calculated, and at the end we will add up all these change in potential energy or work done that will be equal to the total work done 40 Newton meter or joules in taking or stacking 10 bricks over each other. Here is the important note regarding to the solution of the numerical. Again, I am repeating, as we have to calculate the work done in stacking bricks, means that work done for vertical direction or work done by gravitational field only. We need not to calculate the work done for the horizontal direction. We can say the work done by some other type of forces, a constant or variable force, and we also neglecting all the frictions here. Frictions are due to the table and brakes and air friction and all other type of external forces. And the other thing is that the first brick change in the potential energy will be 0, but the potential energy of the brick will not be 0 because it is maintaining some height from the center of the earth above the surface of the table. So we cannot say the potential energy of the first brick is 0, but the change in potential energy will be 0.